Welcome to Coding for Hackers, a self-learning approach. In this session, we are going to understand Unix, Linux and Mac operating system based shell scripting. Before proceeding further, I would like to show you that we will be using a Kali Linux shell. I have connected to this Kali Linux shell over the cloud, and the cloud which I am using is Amazon Web Services. You can make use of Kali Linux operating system in a VMware, or in case if you have a live operating system running, you can quickly follow the session. In case if you have the installed Kali Linux available as well, you are free to use any of the Linux based shell or Kali Linux shell in order to pursue with the demonstration which we are learning in this particular session of Unix and shell scripting. Let's get started. So as far as Unix, Linux and OS X shell scripting is concerned, when we look at the tools we have available to develop shell scripts, there are two main categories: Unix-like shells and Microsoft shells. In this section, we will be discussing Unix-like shells, and we will cover Microsoft shells later as soon as we progress in the course. Shell availability and choices. Unix-like systems, including the many varieties of Unix and Linux, as well as Apple's OS X, have a few common text-based shells. We can typically find the conchshell, Z-shell, Seashell and bash shell either already present or easily installable on the vast majority of the Unix-like systems we might encounter. Please note, as of OS X, first seen in 1999 and continuing to the present, Apple's operating system is based on a Unix-like kernel called XNU, which stands for X is not Unix. OS X is effectively a modified Unix operating system behind its stylish interface and is compatible in many areas with similar Unix and Linux derived operating systems, including the text-based shells it uses. C-shell compatible shells. The C shell, commonly known as CSH, is written in the C programming language and uses a scripting style generally similar to the C programming language. CSH was created with an emphasis on use at the command line. It provides features to aid in such efforts such as command history, command history and file name completion. Functions much rarer in the world of shells when it was developed. Due to differences in the way the shell functions and the way scripts are written, CSH is almost entirely incompatible with shells outside of those immediately related to it. A descendant of C shell, the 10x C shell, otherwise known as TSH, was released by Ken Green in 1983. Ultimately, TCSH is CSH with the added or enhanced features for command history, editing and file name completion merged in. For systems that ship with a CSH-like shell installed by default, we are likely to find that this shell is actually TCSH, as this is the most actively developed and maintained shell in the C shell family at this point. So I hope you are clear with what a C shell compatible shells basically are. So you are aware with C shell and a TC shell, which is known as 10x C shell, and it comes with some advanced features for command editing, history, file name completion and more. Now let's get started with the bone compatible shells. The Bone shell, often called simply SH, was developed by Stephen Bone in the late 1970s and is a common ancestor of several other shells, including the Bone again shell, K shell and Z shell, just to name a few. Among these shells, we can find a variety of common features. The Korn shell, named for its developer, David Korn, was developed at Bell Labs in the early 1980s. The Korn shell, commonly called KSH, supports some handy advanced programming features such as the ability to perform floating point math and the use of more complex data structures than some of the other shells allow. While KSH or your Korn shell does indeed support features that may allow for easier or more efficient development, it is not as commonly found on Unix-like systems, and we are less likely to find it in place as a default shell than we might be find one of the other Bone variants such as bash. So bash is one of the most commonly used variant, and we will be using bash as soon as we progress further in the demonstration. Let's come to the Z shell. The Z shell, often referred to as a ZSH, is frequently considered to be the most feature-rich among the Bone-like family of shells. Seashell was developed in early 1990s by Paul Falstad at Princeton University. Falstad incorporated a great many interesting features when creating Seashell, including enhanced command completion. You can quickly use tab key and the command will be completed automatically. The ability to use add-on modules for additional features such as those needed for networking or more advanced mathematics, and the ability to make use of enhanced and more complex data structures for programming. The born-again shell, commonly referred to as bash, was developed by Brian Fox in late 1980s for the use in the GNU project. Born again is a reference to the Bourne shell as we have discussed above. Ultimately, the bash shell is the text-based shell we will most commonly encounter on a Unix-like system. Many Unix and Linux systems as well as OS X supply a bash shell as an installation default. We can also find the bash shell ported to Microsoft operating systems, although we are not as likely to find it there as we are the native text-based shell. Due to it being such a common shell, the rest of our discussion in this chapter or in this particular course series will be related to Unix-like shell scripting and the examples we will be developing for these particular systems. For Unix, we will be mostly using the bash shell as I'm already speaking on it. So we'll focus on the use of the bash shell. We can typically find bash on newer operating system versions as well and Bourne on the older ones. While there is no guarantee we will have access to bash on a system in any given penetration testing engagement, the likelihood is much higher than that of finding other shells already present. So what kind of other Linux-like or Unix-like shells are available? Absolutely, in general, if I tell you there are a large number of other shells for Unix-like operating systems we might find on any particular system, ranging from one slightly different, such as the compact BusyBox shell. And you will be glad to know that a BusyBox shell could be available on a very lightweight operating system just of MBs, to truly different altogether like the Ghosh shell as well. For almost any purpose imaginable, we can find a specialized shell or a clone of an existing shell with an altered set of features. Thankfully, we will also usually find the more common shells present, typically at least 2 or 3 varieties on a given system. While some of these other shells might indeed be well suited for some specific purposes, we are often better off sticking with the most commonly deployed and installed shells. And in the penetration testing environment, if we are considering Kali Linux operating system, then mostly we will be sticking to the bash shell. Now we'll proceed to working with the shells. Identifying the shell we are in by sight can be tricky, since they all behave differently. Knowing which shell we are dealing with is important. A number of features may be different among the shells, the way they generate random numbers, the built-in commands that are not present, the environment variables set in many more. Thankfully, there is a simple and sure command we can use to identify the shell we are operating in, and this is ps-p $. By executing this command, we are asking for a list of processes by the process ID -p, where the process ID matches our current process, namely the shell we are presently using. And now let's proceed with the demonstration for this particular part, and how we can quickly do is we can go to our Linux shell. In order to quickly identify the shell in which we are working, we can quickly execute this command ps-p and we can make use of $. So ps will give us a list of all the processes running. Using -p we are going to define the ID, and using $, we are going to identify the current shell in which we are in. So as soon as we execute that, we quickly find that we are onto a bash shell. And as I already told you, that bash is one of the most commonly used or mostly available shell available on Linux or Unix like operating systems. If I explain you the command in detail again, so we have executed a list of all the processes to find their process ID and only display the process ID which matches the current process. And using this command, this is to match with the current process, this is to display the process ID, and this command is used to display a list of all the processes running in the machine. So by using this command, we have got that we are currently into the bash shell. So now as far as the bash shell is concerned, we can also enter into a new shell simply by issuing a few commands. There are some shortened name of the shell as a command, and you can quickly use, let's say you can use CSH to move into a C shell, or ZSH to move into a Z shell, or TCSH to move into a 10x shell. When working with shells, entering a new shell is actually adding another layer of shell on top of the shell we are already using. For example, if we were already in our bash shell and we typed bash again, we would be using 2 shells deep. In order to return to the original bash shell, we would enter the exit command, and let me show you what I mean by this. So what exactly we have is, currently we are into the bash shell, and now let's say in case if we want to execute something like, I will execute man. There is no manual entry for CSH is available. On Kali Linux we don't have a C shell available, but let's say in case if I want to go to another layer of the bash shell, I can quickly use bash. So now I will be into another bash shell, and in case if I exit from this current bash shell, I'll come to the proper shell again. There is some other basic shells available which we can proceed to using command sh. So now let's say if I execute sh, so we are again into another shell, and this dollar represents that we are into the next level of the shell layer. We can execute any of the shell based commands here. We can again execute ps-p $. Let's say we are executing this, and now you can see that it defines that currently we are into the sh shell. In case if we want to come out of the layer, we can quickly use this exit command, and we will again come to the bash shell. So this is how you can make use of Unix or Linux based shells. There are multiple types of shells available. We have CSH, we have TCSH, we have conchshell, we have bone shell, we have bash shell. So you have gone into understanding of multiple shells here, and now I hope you can quickly identify in which shell you're working. So once you are done with identification of the shell, you can proceed with advanced technologies for shell scripting. For any kind of ethical hacking programs, join Hackveda. Thank you so much for watching.